The same. There was error loading your app. I don't know. Can you see me?
Yeah, we can see you.
Okay. Oh, I don't know what's the reason, but
Try sharing.
Ah, okay. Okay. Not a problem, I think.
So today's topic is ELB and the problems discovered from this, right?
Yeah. Yeah. Okay, so let's get started. Maybe as an introduction, you know, disadvantages of Mag is that I don't have paint here, so you know, consider twice before buying macOS. But the thing is that we have. Oh, stop playing with it, guys. So the thing is that we have RTB and we have, yeah, you know, this is a fleet of RTB, but let's consider single instance. Okay. There is a message that I'm presenting, but let's do it again. What now?
You can see on the screen, like there on double check. Okay.
Much better.
Okay.
Are we okay with this? I think the projector is.
Yeah.
It's fine.
Okay. So our you know, like entry point was that we have RTB, a fleet of log collectors, ELB between, and what's more is that. Okay.
So it was all about connecting our RTB selectors to log collector.
Yep. And this is like AWS autoscaling, AWS autoscaling group. Yeah. So we have like a custom protocol between RTB and log collector, and this is a TCP-based protocol. So yeah, and we wanted to check. The most important thing is was to check how ELB behaves when it comes to TCP connections. Is it a direct connection between RTB and log collectors, or is there a middle man in ELB which proxies that connection? We wanted to check how it behaves when we lost a log collector, how it behaves when we scaling, auto-scaling groups, and so on. So yeah. So maybe a few words regarding ELB and EWS. So the very first thing is that we want to, while creating ELB instance, we can specify if this is a TCP protocol or HTTP protocol. And this is a very important thing. There is quite a huge difference between them. And what's more, when you are looking for any information on the internet regarding ELB, you must be prepared that if not specified, they're talking about HTTP. There are very few information regarding TCP. So that's why we are testing it, because we need to check it manually, as you know, as experiment. So yeah, our ELB is a TCP, uses TCP protocol. I'm now in AWS console. We see instances, and okay, when it comes to that connection between ELB and autoscaling group, is that when creating autoscaling groups, you are specifying ELB load balancer connected to it, so that is when your group is scaling up or down, ELB automatically see more or less instances. For now, we have the only one.
That's not actually true. It's the opposite way. So if you are scaling up or down, machine is inspected by the ELB, and if it answers the health check, then it is enabled in service or get out of service.
Yeah, I'm just talking that when group is scaling, we do not. There is no need to add this instance somehow manually. It will appear here, but yes, health check status of the instance will be checked by the ELB. Is that right?
So there are two phases. So first, the EC2, newly spawned EC2 needs to answer itself an internal health check. So it needs to boot up properly and then report a EC2 health check. And then after that, because the autoscaling group is connected with the ELB knows that this instance needs to be health checked by them, but there's a different kind of health check. So there are two levels of health check here.
Yeah. Okay. Yeah, that's right. I will talk about it. Just wanted to say that when the group is scaling up, load balancer automatically will handle that there are more instances, like connecting net connections to the ELB when instance is up and running will come to these new instances.
Yeah, okay, got it. Sorry for interruption.
Okay, so next thing is health check. So this is a ELB health check, which can be or not different than that one using with autoscaling group. So in that case, because log collector will listen on TCP 5000. We specify this is a health check endpoint, and load balancer ELB will do like a random request to that port to check the status of the instance. And yeah, we can specify what does it mean that instance is healthy or not. So it's not like the single request; it can be two or more. To change the status. And yeah, listeners is like our connections. So in our case, ELB 5000 port will be instance 5000 port. Nothing to add more. And this is monitoring. It's a CloudWatch ELB service, AWS service. And we will see, basic information about the traffic. But for it's like we have automatically some kind of statistics for ELB, for instances. So for instance of our services, you will see another statistics regarding CPU utilization or network traffic. Okay, so that's it. Just quickly, let's take a look at our autoscaling group. Okay. So this is our autoscaling group for log collector, and basically we can specify, or maybe first how it works. So you have auto scaling, you have auto scaling group, and you need to specify how to, you know, what is the policy of scaling it. So basically, we need to specify minimum and maximum number of instances and desired. So desired is, you know, when everything is up, there will be, you know, number of instances available, and then these parameters, you know, is just regarding auto scaling. Another thing is that what Wojtek mentions already, it's a health check type. So, you know, auto scaling, auto scaling by default, if you do not, there is no need to specify any scaling policies. So by default, auto scaling group will take care to, you know, to have required number of instances using that kind of health check type. So for now, EC2 is specified. So, you know, each instance provides some of the information about the status of that machine, and auto scaling group uses it to have an information about if that instance is okay or not, and it will you know, remove or add new instances by default. But if you want you know, something more complex, especially when you want to scale your auto scaling group in accordance to the traffic, or, you know, or CPU utilization, you need to specify a policy for it. So it's like, you know, you can create you can create alarm for it, and you can specify what kind of metric you are interested in. These metrics are provided with the CloudWatch, with I mentioned. So these metrics are by default available for each instance. You can check it and show it. Yeah. So in accordance to your rule, auto scaling group will scale up or down. Yeah, and this is maybe Wojtek, if you could help me. So from my point of view, I was looking at it yesterday. It's like the only way to you know, to specify auto scaling for our group when it comes to any, you know, CPU, any kind of load. There is no there is no way to because one thing which I didn't mention is that ELB itself is a service, is a machine, and it can scale up or down. We don't have any, let's say, impact on that, but under the hood, it will scale up or down. And what I see is that it doesn't depend. Auto scaling of our auto scaling group does not depend on ELB scaling. Is that right, Wojtek? So the only way to specify, you know, scaling record in accordance to the load is that using these policies for auto scaling group.
Yeah, so answering the first part, yeah, the ELBs and amount of instances under the ELB is totally independent regarding the ASG size. So those two services are totally independent. That's why you need to have the pre-warming or warming up the ELBs in order to have the full throughput and a scaled up ELBs. The ELB is under the hood is a series of machines which HA proxy or something, which are either beefy or smaller depending on the amount of load that you are receiving. And if you are receiving more load than they anticipated, they are enhancing your fleet underneath. And regarding the second part of the question, yeah, if you will limit yourself to the CloudWatch provided metrics, CPU utilization or other stuff defined there is the only way. However, you can export your own custom metrics from your instances. So there is no need to limit yourself and create alarms just based on the CPU utilization, RAM utilization, and so on. You can expose yourself a metric, for example, amount of requests incoming to the RTB selector, and then depending on that, you can either create an alarm or scaling policy based on that particular custom metric. If I recall correctly, that's possible.
Okay, thanks for clarification. So that's it. There is no need to describe anything more, or maybe when some questions will come. And any questions for that part? So now I want to describe the testing procedure and explain the test itself. Can we go ahead?
One question regarding CloudWatch. Is it like real-time reaction or it has some lag? As far as I remember, there was some 5 minutes lag.
You have lag. I don't know the lag. That 5 minutes is like a precision for the diagrams, for the graphs. So there is the the smallest part of time you can see the graph, but the CloudWatch itself, or maybe you are okay. So yes, you can see it that way, because when specifying, let's see.
So on the graph I can see 5 minutes.
Yeah, 5 minutes, and what's more, when you want to specify policy, there is the nothing less than 5 minutes. So from that perspective, we can say that. Okay.
1 minute.
1 minute.
Oh, or 1 minute. Okay.
And if I recall correctly, there's the 1 minute is also available via API. So that's the smallest, smallest possible aggregation available. However, I find out that in Datadog you are not limited by any. We'll see how if we'll integrate it, but in Datadog, at least in documentation, there is no remark regarding the limitations regarding aggregation and minutes regarding integration between the AWS. So hopefully, external services, probably because of the amount of API calls, will be able to lower down this granularity.
Okay. So yeah, for the diagrams, you can also use a 1 minute period.
I think it's not that bad. Like 1 minute is enough, probably.
Yeah.
But I just want to clarify. We need to take it into account.
Okay. So about my test. So I started with I didn't use real services because there was no need. By the RTB side, there was a simple TCP client. By the log collector side, simple TCP server, both written in Python. To confirm some of the tests, if I have some doubts, I was just using like Linux console TCP client just to confirm some some behaviors. And I've prepared just like my working document. I just specified some of the scenarios and the result of that. So the procedure was that in accordance to the procedure, I was starting client server, looking what is happening, and then like confirming it using TCP dumps. The client itself in Python is that TCP is sending a message and servers is sending the same message back to the client. So the very first thing was to verify, do we have like a direct connection between RTB and log corrector, or is there a middleman between? So the result is that ELB proxies connection between RTB and log corrector. So it's like when connecting to the when connecting and specifying ELB TCP address, you have two connections: one between client and ELB, and second one between ELB and server. So the result of that is that even there is no server running in the ELB, none of the service is healthy, you are still able to connect to the ELB and sending the messages. So it looks like your client is connected, sending messages. Your client is receiving acknowledgements, TCP acknowledgements, and receiving empty messages in that case. Next, when you set up servers for your client is still running, you set up new servers. It won't automatically, there is no kind of switching the traffic or something like that. You just need to reconnect by the client side, and then communication will start. So there will be a connection to that server. Then when having that communication running, when you shut down your server, your client is still connected to the ELB and is receiving empty messages and TCP acknowledgements. So from the client point of view, nothing changed. So yeah, and then if you set up some new servers, you need to reconnect by the client side.
I think I have the same question. No problem. So
let's see.
When you said that when you close the server, the client is still connected to the ELB. So it means that ELB does not proxy the FIN packet from TCP, because you shut down the server in a proper way, so the connection gets terminated. We should send the FIN packet right to the client, and the client should tear down the connection on their end.
I suppose that there's no FIN packet on that side, because FIN is received by the ELB from the other side.
Yeah.
There are actually two TCP connections.
Yes. So okay. So but it means that.
But yeah,
ELB
but the question was if it proxies.
Yes,
No,
that does not propagate this. So like the other end has no way of.
has no information.
Okay.
But that's like how load balancers should work. It should hide the fact that server is is gone.
Right.
What noise connect to the other?
But in kind when it comes to, we have TCP ELB. When you have HTTP, okay, your client will receive appropriate HTTP code. When it comes to TCP, there is no way by the client side to check that communication is lost. Because we are talking about
packets oriented, so
Yes.
not like message oriented, it's like packets, right?
In our case, when it comes to log collector, there is no like a confirmation payload from the log collector side, so RTB won't have any way to check that communication is lost.
One more question. What is empty message? It is another TCP packet sent like explicitly to you? Or?
Oh, sorry, I don't remember.
Like,
yeah, I know what you are. Yeah,
you receive another message, another packet.
Yeah, you are just asking if ELB really sent anything in response to the message. Let me check it later. I don't remember. for sure we are receiving acknowledgements. Okay, so I've described some of the scenarios, so we will go deeper. Okay, so after that initial test, I was looking for another solutions to, I don't know, configure ELB in some way to change the customize this behavior. Unfortunately,
quick question.
Yeah.
Do you have a scenario when you've got two servers and one client, and you are disabling one server?
Yeah.
Okay, so no worry, you will probably talk about it later. Sorry.
Yeah, for sure. So yeah, after that initial findings, I was looking if there is any ELB configuration. Unfortunately, there are very little settings available for the customer. One of the things which Wojtek proposed was to enable proxy protocol in the ELB. So it works like because in that model of communication between client ELB and server won't know what is the real address of the client. So in the TCP dumps, you will see ELB IP as a source of the stream. So proxy protocol is like you are enabling it on the ELB side, on the load balancer side, and just before any communication with the client. So there is like a TCP handshake between ELB and the server normally, and just after that, in the first message, it's a payload of the packet. Server receives that kind of header, which tells what's the real IP address of the client. Yeah, but only it's like only server will get the IP address of the client. A client won't have any information about the server. So what's important is that this header is only sent in the payload. So this enabling this protocol won't change TCP headers. So you still will have like a source or destination address, and it will be ELB IP address. So from my perspective, I don't think this is any advantage for us. I don't see how we can use it without any major modifications to our protocol. So yeah, after that test, I just drop it. Don't know if you have any experience with that or any opinion, but to me it's useless.
So if there is no server on the other side, we won't receive this proxy something.
No, because this is sent by load balancer to the server.
Okay, can I answer the question? Is there any server out there looking at this proxy?
No.
Like
From the client side.
Mm-hmm.
No. So
that proxy header, as Sebastian said, is sent only from the ELB to the server. So you need to actually have the confirmation on the application side and resending it to the client in answer.
So the possible solution would be that there is a ELB is running, server is running, and your client is looking for that first message from the server. But by default, no, only message from ELB to the server. Okay, there was some.
Okay, but
Hmm?
hold on a sec. So just let me, if I understood it correctly. So this is a way of just using load balancer as a kind of like IP, discovery, like register, because like I'm a client and I can wait for this proxy TCP, read the address, connect directly to the server, right? And then if connection is terminated by the server, I can connect to ELB again and get another IP, right?
Yeah, but that's the problem. You are not, the connection to the ELB from your side, even if there's no server, is not terminated by itself. So you are actually, you don't know that you are sending to the dev null. That's the whole problem.
But hold on a second, but I don't have to use ELB to, direct traffic, and can use ELB as some kind of service discovery mechanism.
Yeah, that's another solution that I proposed to Sebastian in private. So we can leverage this proxy TCP.
Yeah, sorry.
So we can leverage this proxy TCP header and resending it to the client and then directly connect. But this requires actually modifying the log collector source code.
Why log collector? Why log collector?
Because log collector is receiving the proxy TCP header and then it needs to resend it.
Ah, okay.
So possible solution is that log corrector is receiving that header, sending it to RTB, and RTB.
Okay, I thought it was the other way around.
And actually, that's my also initial thought. I don't know why this proxy TCP is the other way around that you are supposed to be. I don't know why server receives the proxy TCP header, not the client, but never mind.
Maybe for tracking, like if you want to know a real source address.
Exactly, that's the main purpose. So they are
the solution. Let's say AWS on their site describe it as a solution for the for the server to know in your logs what was the client. Yeah. So it's just like a possible solution for tracking the real.
Maybe it was a server that would like to know the client IP, not load balance.
Yeah.
And moreover, you need to handle that IP by yourself because they are not modifying TCP headers by anyhow. So server is receiving the ELB IP, not the real client.
That's right. Makes sense. Okay, just a quick check of
like how it's supposed to receive a normal client IP. It would require a lot of connections. Defies the purpose of the load balancer. No, it's possible, I think. But there is like a header because I understood. Well, okay, we are talking about TCP load balancer. Never mind.
So the next check was next test was like a quick check of the situation with long-running connections. So there is a configuration in the load balancer ELB. Let me find it. Okay, so this is idle time by the ELB side. So it's a time after which a connection will be terminated. So in that time, if there was no communication from the client side, connection between the client and the ELB also will be terminated. So yeah, just a quick test. Yeah, it's working.
This idle timeout.
We wanted to check what will happen if if there are some RTB clients having nothing to do.
Yeah, but that will not happen in our case. That's the main problem of idle timeout.
Yeah. Just it was like a quick shot, so I check it. Okay. Maybe let's move on.
small suggestion. Flow diagrams would be very useful here. Like, I know if the correct name is.
Okay.
Stripes.
Let's skip it. I will come back to these scenarios. There is another case, test case when we have normal communication but multiple servers. So let me check what I was testing. So it was like we have multiple servers running. I'm running client. The client is connected to the, there is a connection to the ELB and ELB to one of the servers, and I'm shutting down the server that is receiving that traffic. So yeah, as we may expect, client is still receiving TCP acknowledgements and that empty messages. So the behavior is exactly that if we have one server and we are shutting it down. So no surprise here.
Do we have empty messages when everything is working?
Sorry?
Do we have empty messages when connection is okay? Like there is a server client and a balancer, but it's sending empty messages too? Or like we discover we receive empty messages, can we assume that something happened on the other side?
In my situation, yeah, because I know that.
So it might be, I know, trigger for us to reconnect, right?
In case of it depends on your application. In our case, not, because log collector doesn't confirm.
Okay, it doesn't confirm, but so I expect nothing when I receive empty message.
Okay. You are talking if there is a real packet with no payload. Yeah. So let me. You asked about it previously.
Yeah.
I will check it just after.
But this is ask, right? This packets. So
that's my question. If it is ACK or another TCP packet with empty body.
I think that there is ask only, but I will check it, or maybe we will see just after
Yeah, but that's actually a very good question from Pavel, because if that will be an ACK, why the client is interpreting this as an empty message?
Yeah, it should be transparent.
Exactly, that's a totally different thing than the payload, the packet with the payload.
Yeah, that's right. That's right. I don't know if that's the. Oh, I will check it later. Okay. So yeah, so we can come back to that. This is a part that that uses connection draining or on the ELB side. I don't think maybe it doesn't matter in terms of our problems, but let's describe it quickly. So it's like you can set it, but by the ELB side, and this is a this is a time you have some instances of servers connected to the ELB, and then when some of the server is going down, is unhealthy. This is a time when connection will be for which connection will be up, waiting for completing messages or let's say a request or already sent. So you can in case of scaling down, it may help. I don't think there is any advantage of that when it comes to TCP connections, because in my test, behavior was as I expected. So our server was going down, and after some time I just saw that client is receiving no messages. The same behavior when it comes to multiple servers by the ELB side. So I don't see any purpose of that. I don't know, Wojtek, do you have any comment regarding it? Because maybe I'm misunderstood the behavior of that draining.
Yeah, so draining will be used definitely if we will use stage rollout. So thanks for that cases, because if we will aim in stage rollouts, we need to focus on setting up properly the draining as well, because that's the main problem with the stage rollout. You need to set up properly time when it comes to getting machine down and finishing up the connections, because machine marked to a stage that will be rolled out and replaced with the new version is marked as a machine with only old connections, and then you are waiting until all connections will be drained, and then you can kill the machine and spawn a new one. So basically that's the purpose, and that's the use case for the connection draining, and that will definitely help us when it comes to stage rollouts in the future.
Okay. So 2 tests left. Let's skip it. DNS for now. Regarding ELB, I was testing auto scaling, scale up and down. So the test was that I modify auto scaling group to have minimum 1 instance and maximum 2 instances, and the scaling policy was set on incoming network traffic. So yeah, it's quite good by the auto scaling group is that you can also set warming up uptime manually, so no request will come to that server in that time. So the very first connection may be created after warming up. So in my test, I set that policy. I set the policy of incoming network traffic. I was starting new clients to see how it behaves. So after I reached the threshold, new instance was started by autoscaling group, and there was no impact on the running clients. Just new clients were connecting, were connected to the new instances, and then I killed some of the clients to be below the threshold of the network traffic, to see what will happen when scaling down. So the result was that the server instances, the new instance was moved down, and the client connected to that server started receiving empty, let's say, messages. So the behavior was exactly like in the previous scenarios when we just shut down one of the servers. So yeah, no surprise. But when it comes to scaling itself, I think that, as Wojtek said, it requires our configuration to set these times in accordance to our application, but it looks and work quite good. Yeah, so after that, I've discussed with Wojtek what was next, because the initial initial thing for preparing that test was communication with reporting guys, with log collector guys, and they said that there might be some problems with that. So Wojtek, as alternative solution, proposed DNS with round robin policy. So we have like Route 53 DNS service by the AWS site, and we can create records with multiple endpoints, and then specify policy to switch to another another endpoint. So in that test, I've set up a single entry, 2 instances of server, a single DNS entry, and with entry with that 2 IPs for that machines. And I've used a simple policy which is round robin, and server, and client. So RTB in our case was connected to that DNS entry, to that DNS, uses that DNS name. So we expected behavior is that next IPs are returned by the DNS server in a round robin fashion, and yeah, it was exactly like that. So we start first client, and first server started handling this traffic, and the second client was connected to the second server. The good information is that in that connection, in that situation, we have direct connection between client and server, and when server is down, we are getting information that connection is lost, so we can handle it.
Question: do we get all of the IPs but shuffled, or this is just a single IP when we resolve the DNS name?
When we resolve, there is a single IP address.
Okay.
Yeah.
Okay. Cool.
How would it work with like 10
Yeah.
or like 3 RTB selectors and 10 laptop collectors?
Yeah. So the thing is that we will need our custom scripts to automatically set up. Would be like we have that